Hello everyone. So in this second part of basic SPSS, I will show you how to use SPSS to perform linear regression. Linear regression is a commonly used method in statistical analysis. So we'll see how to use SPSS to do some basic regression. So let's open the data file. So this data file is in the form of um, an Excel file, but it's in CSV format. So, okay, so as usual, we load the data. Okay, so if you look at the data, it contains brain and body mass uh, information for 25 animal species. Okay, you can see a cow, gray wolf, goat, and so on and so forth. So here the body mass is given in kilograms and the brain mass is given in kilograms as well. Now for starters, we could actually just do some basic data exploration by making a scatter plot, for example. So we could do a chart builder with a scatter plot. Okay, so we just want to look at the simple scatter. Okay, so we drag this and put it here. Right, so now we would in this problem, our x-axis should be the body mass because it's something that we can measure easily. And from the body mass, we want to predict the brain mass. Okay. Right. So if there's some kind of linear relationship, so that will be very useful because we could predict the brain mass by just measuring the body mass. Okay, let's click OK. So this is the scatter plot. Okay, so apparently you are not getting much. You can see over here. Um, these are the most of the data are clumped over here, and then there's a large spread. Primarily because most of the animals have body mass that's below. This is about 1,000 kilograms, but there are a few animals with very large body mass. So if we just study the relationship between these two variables at the original scale, um, it is very hard to see that there's any form of linearity. Okay. In fact, in the original scale, the relationship seems to be following some kind of curved law, something like this. Okay. So what should we do? So one approach is to take logarithm of both variables. This would compress the large values to smaller values and reduce the variation on the x-axis, right? Also on the y-axis. So with that kind of transformation, if you do linear modeling, the linearity pattern may actually appear. So let's see how we do transformation. So in SPSS, we click on transform compute variable. Okay, so we will want to take log of our body mass. Let's look at some arithmetic. So we take the log base 10 for ease of interpretation. So for example, if it's a 100 kilogram animal, you take log base 10, so you get 2. So if the animal is 1,000 kilograms, you take log base 10, you get 3. So that's easy to interpret. So first we put on the log This is the body. We want to transform. Um, okay, so log base 10. So actually, you could just type it like this. And we call this new variable log of body. Okay, click OK. So then a new column has been created. And then we do another one for the brain mass, log of the brain mass, right? So this one we call it log brain, and then we change this to brain. Okay, and click OK. So there you go, right? Okay. You can see that the all the values, almost all the values here are negative because most animals have brain mass that's below 1 kilogram. Okay, so now let's look at the scatter plot. Again, between the log of the body mass and the brain mass, we're going to choose, we could actually put a fitted straight line through the data points. So here, put log of the body on the x-axis, log of the brain on the y-axis. So let's try this again. Okay, so log of the brain on the y-axis, log of the body on the x-axis. Click OK. Right, okay. So this looks pretty much linear, right? In fact, could fit a straight line through it. We want the fitted line. Okay. Log of the body here, log of the brain over here. Try to click OK. Right, okay. So there we go. So the linearity seems to be a good fit for the data, right? So once we have this preliminary exploration, we feel that the linear model is a proper model for modeling our data. So in that case, we can straight away go to more inferential statistics, analyze. On the regression, we choose linear regression. Okay, so the dependent variable will be the log of the brain. The independent would be the log of the body. Okay, you can click OK. So the result of the linear regression comes out over here. So over here you can see that these are the regression coefficients. This is the intercept coefficient, estimated to be about -2. The regression coefficient for the log of body is 0.75. Okay, and both of them are statistically significant. And the result over here for ANOVA gives you some idea about how well your regression model fits the data. And as you can see here, the fit is very good since your p-value is extremely small, and you can check over here the accompanying statistic. The R-square is actually very high. It's about close to 92% of the variation in the log of the brain size is explained by the log of variation in the log of body size. Okay, so so how does our model look like once you have this information? So let's go to some tools here. You can open board. So I'm going to write something. Okay, so just now the regression model that we had was the log of the uh, brain mass was estimated to be about -2 plus 0.75 log of body. Okay, if I got that correct. Okay, so so if you wish to express this in its original scale, you would do some uh, transformation over here. So you take 10 to the power of -2 plus 0.75 log base 10 body, which is basically 10 to the power -2 multiplied by 10 to the power of log 0.75, right? So basically this is 0.01, so that's 1 over 100. Okay, over here you have body 3 over 4, raised to the power of 3 over 4, right? Okay, so let's get back to the model just now. Okay, this is our model. So basically, you have something like this. Oops. 1 over 100. So this is a body cubed raised to the power 1 over 2, 1 over 2, right? So basically, what this means is that you could actually, your model is actually pretty nice. You could actually take your body mass in order to predict the brain mass of a vertebrate. You could actually take the body mass, you take the cube of the body mass, and you take square root once, and then you square root it another time, and then you divide by 100. Okay, so this gives a very simple rule to make predictions about the brain mass given the body mass, right? And all this is made possible by first producing a linear model at the log scale using some software like SPSS or some other suitable tools. And then from the output of the test, the statistical test, you could actually do some simple mathematics, and you can come up with a really nice model to summarize your data. Okay, so I hope this has been useful introduction to how to use SPSS to produce simple analysis.